Hello dear students, I am Pratima. I welcome you all to this video. So today we are solving questions of exercise 8.2 Ncert class 9 questions based on midpoint theorem. Coming to question number 1, ABCD is a quadrilateral in which PQRS are midpoint of the side. P is midpoint of AB, Q is midpoint of BC, R is midpoint of CD, S is midpoint of DF. You have to show that SR is parallel to AC, SR is equal to half of AC, and PQ is equal to SR, second part. Third part, PQRS is a parallelogram. So many parts are there. You have to go one by one using, of course, midpoint theorem. What midpoint theorem says? Midpoint, this is the rough work, no need of writing in the examination. Midpoint theorem says if you will join the midpoint of any two sides, this line segment is parallel to the third side and parallel equal to half. DE is parallel to BC, D is equal to half of BC. So first I'm going for this part. The figure is given, no need of to draw anything or write anything. So first I'll write in ADC triangle, in ADC. So for part 1, in triangle ADC, S is midpoint of AD and R is midpoint of CD. So by theorem, I'll write SR is parallel to AC, SR is equal to half of AC. Part 1 is over. Now coming to second part. Second part, I'll go for ASB triangle. This triangle will go. In the same way, I'll write P is midpoint of AB, Q is midpoint of BC. So in triangle ABC, P is midpoint of AB, Q is midpoint of BC, then PQ is parallel to AC, PQ is half of AC. Then from SR is half of AC, PQ is half of AC. So from two relation I can write this is 1, this is 2. So from 1 and 2 I can write SR is equal to your PQ. Second part is over. Now coming to third part. In the third part, I'll go for this line. SR is parallel to AC. Then PQ is parallel to AC. That means SR is parallel to PQ and SR is equal to PQ. SR is equal to PQ, SR parallel to PQ. So PQRS is a parallelogram. So this result is very important to prove other part of other questions. What is it? I'm writing again. You can write down and remember the line segments joining midpoints of sides of any quadrilateral form a parallelogram. So whenever we'll come to this situation, first we'll say that it will be a parallelogram, then we can go for others. So this is the result I have written below on the screen. Now coming to question number 2. You can read the question. ABCD is a rhombus and PQRS is the midpoint of the sides of AB, BC, CD and DA respectively, so that this quadrilateral PQRS is a rectangle. So now we are joining the midpoints of a rectangle and we have to prove that it will form of a rhombus. We prove that it will be a rectangle. So let us draw the figure. So ABCD is a rhombus, name it. Now I'll take the midpoints. This will be named as PQRS, 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 PQRS. Let us join it. What will form? It will form a rectangle. We have to prove that it will be a rectangle. So what is the property of the rectangle? Rectangle is two diagonals are equal. That is the most important property. So we have to draw the diagram. Diagonal. Two diagonal drawn. Okay. So now I'm writing what is given. Given ABCD is a rhombus. That means AB is equal to BC is equal to CD is equal to AD. Now P, Q, R, S are midpoint of AB, BC, CD and AD. To prove, we need to prove PQRS is rectangle. So we have to keep in mind that in a rectangle diagonals are equal. We have to prove the diagonals are equal. Now, what is the construction? Construction is I join the diagonals. Join P, R and SQ. Okay, now I'll come to proof. First I'll write that it is a parallelogram. PQRS is a parallelogram. Why it is a parallelogram? This is the logic that we know, as we know that line segments joining the midpoint of the sides of a rectangle forms a parallelogram. So it is a parallelogram. Part is 1 is over. Now extra property is diagonals are equal. How to go for diagonals equal? Now I'll write that BQSA is a parallelogram. Why? Because BQ is parallel to AS and BQ is equal to AS. Why? BQ is half of BC and AS is half of AD. BC is equal to AD, you know it is a rhombus. So BQ is equal to, so BQSA is a parallelogram. So when it is a parallelogram, I'll write AB is equal to SQ. Now coming to in the same way, I'll prove PBCR. PBCR is a parallelogram. Why it is a parallelogram? Same logic. What is it? BP is equal to CR and BP is parallel to CR. So here I am getting BC is equal to PR. This is relation 1, this is relation 2. We know that AB is equal to BC. So from 1 and 2, PR is equal to SQ. So since diagonals are equal, PQRS is a rectangle. So what you have learned? You have learned that if it is a rectangle, a rhombus, the line segment joining the midpoints will be a rectangle. Now what will be the opposite of it? It will join the midpoint of a rectangle. What will form? Certainly it will form a rhombus. Now let us come to next question. It is same question. Question number 3. ABCD is a rectangle and PQRS are the midpoints of sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. Got it? So now we are taking the opposite. First we are taking a rectangle. We are joining the midpoint. We will find that it will form a rhombus. So what is the property of rhombus? Sides are equal. It will form a parallelogram because we are joining the midpoints. Only we have to show that the adjacent sides are equal. So of course we'll join the diagonals. Two diagonals will join. So this is the construction. So let us write what we have written or understood. First is given ABCD is a rectangle. Then your P, Q, R, S are midpoints of AB, BC, CD and AD. To prove PQRS is a rhombus. So what construction we made? We joined the diagonals. Join your BD and AC. Proof. First ABCD is a rectangle, so two diagonals are equal, we'll write. Okay, so here I will write that diagonals BD is equal to AC, Y, ABCD is a rectangle. Then I'll go for PQRS is a parallelogram. You know the logic? See, since P, Q, R, S are midpoints of ABCD. Of sides ABCD. So it is a parallelogram. When parallelogram, then opposite sides are equal. So PS is equal to QR and your PQ is equal to SR. Only thing is left, I'll prove that these adjacent sides are equal. For this, I'm taking help of your PS is half of BD by midpoint theorem, and similarly your PQ is half of AC. Now in triangle ABD, PQ is half of BD and your I'm taking in ABC. In triangle ABC, PQ is half PQ is half PQ is half of PQ is half of AC or BC. And same again I'm writing PQ. Why? This is PQ, this is something else. ABC. It is ABD. ABD is PS. I'll write this PS. I hope you understood. In ABD, PS is equal to half of BD. In triangle ABC, your ABC, PQ is half of AC. PQ is half of AC. And BD is equal to AC. BD is equal to AC. So half of BD is equal to half of AC. So from 1 and 2, I can write PS is equal to PQ. So when adjacent sides are equal, it is a rhombus. So A, B, C, D is a rhombus. Next, I hope you have understood. First we wrote midpoint of a rhombus was a rectangle, then we are writing midpoint of rectangle is rhombus. Now coming to question of 4. ABCD is a trapezium in which it is given AB is parallel to CD. BD is the diagonal drawn, E is the midpoint of AD. A line through E is drawn parallel to AB. When it is parallel to AB, it is also parallel to CD, intersecting BC at F. Show that F is midpoint of BC. So what is given? Given in ABCD, AB is parallel to CD. E is midpoint of your DA, and EF is parallel to AB. To prove F is midpoint of BC. Since drawing is given, we no need, only we'll name this point, let this be P. Now P is the point of intersection of BD and EF. Now I'm coming to proof. For proof, I'll take triangle DAB. In triangle DAB, E is midpoint of AD, E is midpoint of AD, and EP is parallel to AB. EP is same line as EF. So when EF is parallel, EP is also parallel. So by converse of midpoint theorem, P is midpoint. P is midpoint of BD. Because it says if we start from a midpoint parallel, certainly this will touch the midpoint of other side, third side. Now coming to, then I'll take your triangle DCB, this triangle DCB. Okay, so here P we have proved midpoint. PEF is parallel to CD. Why? PF is parallel to AB. AB is parallel to CD. So PF is parallel to CD. So certainly F will be the midpoint of BC. Just logically we are writing. Now in triangle your DBC. In triangle DBC, P is midpoint of BD we have proved. Now PF is parallel to CD. Why? PF is parallel to AB and AB is parallel to CD. So F is midpoint of BC. Hence proved. Question number 5. Question number 5, in a parallelogram ABCD, E and F are midpoints of the sides AB and CD respectively. Show that the line segment AF and EC, AF is this line and EC, they trisect the diagonal BC. Trisect means they make equal three parts. That means you have to prove that PD is same as PQ is same as BQ. So given, what is given? ABCD is a parallelogram. What else is given? F is midpoint of CD and E is midpoint of AB. E is midpoint of AB. F is midpoint of CD. And BD is diagonal. We need to prove of course you can write here AF intersect BD at P and EC at Q. We need to prove DP is equal to PQ is equal to BQ. Prove. So I will apply midpoint theorem. So I need triangles. So first I am taking triangle your APB. I am taking APB. You see APB. In triangle APB, APB, E is midpoint of AB, and EQ is parallel to AF. Why it is parallel? Because why it is parallel I'm writing here, okay? Because as I'm writing here, sorry, as you'll write AE is equal to FC, because both are, why? Because as half of AB is equal to half of CD, and AE is also parallel to FC. So AE CF is a parallelogram. So when it is a parallelogram, then EQ is parallel to F. EQ is parallel to AF, or EQ is parallel to AP. So EQ is parallel to AP, E is midpoint of AB. So certainly Q is midpoint of PB. So when it is midpoint, I can write PQ is equal to QB. One part is over. Now I'll come to triangle DQC. Note it, DQC. In the same way, I'll write F is midpoint of CD, FP is parallel to CQ, so Q must be midpoint of DQ. So in triangle CDQ, F is midpoint of CD and FP is parallel to CQ, FP. So P is midpoint of DQ. What does it mean? It means DP is equal to PQ. So DP is equal to PQ, PQ is equal to QB. So PQ is equal to QB is equal to DP. Proved. Question number 6. Question number 6 is, so that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Okay. So A, B, C, D is a quadrilateral, and P, Q, R, S are the midpoints. His name is not given, we are naming ourselves. You have to show that the quadrilateral diagonals bisect each other, so that the line segments, what are the line segments? P, Q, Q, R, S, this opposite sides quadrilateral bisect each other. They bisect each other. That means you have to prove that line segment joining these SQ and PR, they bisect each other. Okay, so you can pause the video, you can draw the diagram. What is given? Given is P R joining midpoints of AB and CD. These are the opposite sides joining the midpoints. And your SQ is the line segment join midpoints of opposite sides. What is SQ? For SQ, it is of AD and BC. To prove they bisect each other, that means you have to prove that PO is equal to OR and SO is equal to OQ. Proof. So P is midpoint of AB, Q, R, S are midpoint of BC, CD, DA. So what type of figure it is? PQRS. PQRS is a parallelogram. So when it is a parallelogram, we know that diagonals bisect each other. In a parallelogram, diagonals bisect each other. What are the diagonals here? Diagonals are SQ and PR. So PR and SQS bisect each other. Question number 7. ABC is a triangle, right angle at C. A line through the midpoint M of the hypotenuse AB and parallel to BC intersect AC at D. Show that D is the midpoint of AC, MD is perpendicular to AC, CM is equal to MA is equal to half of AB. If needed, you can read the questions again before drawing the figure. This is the figure. ABC is a triangle. It is right angle at C. That means this is 90 degree. A line through the midpoints of M of the hypotenuse. If C angle is 90 degree, AB is always hypotenuse. And M is the midpoint of the hypotenuse. It is drawn parallel to BC. So MD is parallel to BC. You have to show that D is midpoint of AC, MD is perpendicular to BC, MD is perpendicular to not AC, it is BC, and CM I've joined MA is equal to half of AB. Half of AB. Okay. So what is given? Given two things are given. One is C is 90 degree. Other is given M is midpoint of AB. When M is midpoint of AB, that means AM is equal to BM. Now to prove, D is midpoint of AC. So this is the converse of your midpoint theorem. Why? MD is parallel. It is given MD is parallel to BC. MD is parallel to BC. Okay. So M is midpoint of AB. MD is parallel to BC. So D is midpoint of AC. By converse of midpoint theorem. Done. First part is over. Now coming to second part. MD. MD is perpendicular to AC. Yes, it is not BC. It is, the question was correct. What was? It was BC. It was perpendicular. If MD is parallel to BC and C angle is 90 degrees, so D must be 90 degree. Corresponding angle. MD is parallel to BC given and C angle is 90 degree. So that means D is also 90 degree. Why? C is equal to D corresponding angles. So when D is 90 degree, MD is perpendicular to AC. Now coming to third part. Third part is CM. We have to join CM. CM is equal to MA is equal to AB. First, so AM is equal to half of AB. Third part. M is midpoint, so AM is equal to BM and AM is equal to half of AB. Now only we have to prove CM is also equal to AM. How to prove it? CM is equal to AM. You can show congruency. If this angle is 90 degree, this is also 90 degree. CD is equal to AD we have proved because it is the midpoint theorem. By midpoint theorem, AD is the midpoint. So I'm writing the things in triangle MCD and triangle MAD. First is MDA. MDC is equal to MDA. Both are 90 degree. Next is your MD is common. MD is equal to MD. Then CD is equal to AD. So by what? SS? Triangle MCD is congruent to triangle MAD. So when it is congruent, I can write CM is equal to AM CPCT. So CM is equal to AM is equal to half of AB. All the parts are proved. So thank you for watching. We'll continue. Keep on watching, keep on subscribing, and like the video so that your friends can watch.